Hello, good morning viewers. In this tutorial, we are going to learn how to find the inverse of an algebraic function. The inverse of a function is nothing but the opposite of that function. So let me use the first example to further explain what this inverse is all about. Our first example is f of x equal to square root of x. And we want to find the inverse of this function. So the first thing we are going to do here is to replace f of x with y. So we have y equal to square root of x. Next, we are going to switch x and y. This means that wherever we have x, we are going to write y, and instead of y, we write x. So x will be equal to square root of y. Next, we are going to solve for y, or make y the subject. Now to solve for y, we are going to square both sides because square will cancel the square root. So x squared will be equal to y. Or you can write it as y equal to x squared. And finally, we are going to replace y with f inverse of x. So finally, we have f inverse of x equal to x squared. All right. Now look at it. We started with square root of x, but we ended with x squared. And remember that square is nothing but the opposite of square root. So any value inserted here, and you take the output, you insert it into our inverse function, you are going to get that original input. And let us try that. Remember, we started with f of x equal to square root of x. So let x be equal to 4. Therefore, f of 4 will be equal to square root of 4, which is equal to 2. So now this is our output, while 4 here is our input. So if we should take this output, which is 2, and plug it back into our inverse function, we are going to get back our original input, which is 4. So from our inverse function, f inverse of 2, which is our output, will be equal to x squared, which is 2 squared. And remember, 2 squared is 4. And this 4, remember, is our input. This shows that an inverse function is just the opposite of the original function, because it reverses the output of the original function back to the original input. Now let us take the second problem. Our second problem is f of x equal to 2x plus 3. As usual, we are going to replace f of x with y. So we have y equal to 2x plus 3. Next, we are going to switch x and y. So we have x equal to 2y plus 3. Finally, we are going to solve for y, or make y the subject. We can subtract 3 from both sides. So we have x minus 3 equal to 2y. Then we divide both sides by 2. Finally, y is equal to x minus 3 divided by 2. And now we can replace y with f inverse of x. Therefore, our inverse function is nothing but x minus 3 divided by 2. This implies that if our original function is 2x plus 3, our inverse function will be x minus 3 divided by 2. Let us take problem number 3. Our problem number 3 is a function of the square root of x plus 5 all minus 2. All right, now let us replace f of x with y. So we have y equal to square root of x plus 5 all minus 2. We're going to switch x and y. We have x equal to square root of y plus 5 minus 2. Add 2 to both sides. We have x plus 2 equal to square root of y plus 5. Now we are free to square both sides. If we square this side, we have to square this side. From the left hand side, we can expand. First time squared is x squared. 2 times x times 2 is 4x. then last term squared is equal to 4. Then to the right hand side we have only y plus 5. Now we can subtract 5 from both sides, so we have x squared plus 4x. Then if 5 crosses over, it becomes negative. We have 4 minus 5, which is negative 1. This is equal to y. And we can write y as x squared plus 4x minus 1. And lastly, we are going to replace y with f inverse of x. Therefore, our inverse function is nothing but x squared plus 4x, then minus 1. And hence, this is our inverse function, if and only if this is our original function. Now let us take problem number 4. Problem number 4 is a function 3 divided by x squared plus 2. Alright, the first step, we are going to replace f of x with y. So we have y equal to 3 divided by x squared plus 2. Now we are going to switch x with y. So we have x equal to 3 divided by y squared plus 2. And lastly, we are going to solve for y or make y the subject. We can cross multiply. We are free to take this and multiply by this. X multiplied by y squared is x y squared. Then x multiplied by 2 is 2x. Then we take 3 and multiply by 1, which is equal to 3. Now we are free to subtract 2x from both sides, leaving x y squared equal to 3 minus 2x. Again, we can divide both sides by x, leaving only y squared to the left, and this is equal to 3 minus 2x divided by x. And finally, we can take square root of both sides, leaving y equal to plus or minus the square root of 3 minus 2x divided by x. And finally, we are going to replace y with f inverse of x. F inverse of x finally is plus or minus square root of 3 minus 2x divided by x. This is our inverse function, if and only if this is our original function. Now let us take the last one. Our last problem is a function 4x minus 3 divided by 3x plus 5. Alright, first step, we are going to replace f of x with y. So we have y equal to 4x minus 3 divided by 3x plus 5. Next, we are going to switch x with y. So x will be equal to 4y minus 3 divided by 3y plus 5. Next, we are going to solve for y or make y the subject. We can cross multiply. X multiplied by 3y plus 5. X times 3y is 3xy. Then x times 5 is 5x. Then we take this multiply by 1. It is the same thing as 4y minus 3. This is 4y minus 3. Now we can take this to the right and bring this one backward. The sign of all the times will change. So we have 3xy. If this crosses over, it becomes negative 4y. And to the right hand side, we have negative 3. If this crosses over, it becomes negative 5x. From the left hand side, we have y in common, so we can factor it out. We have 3x minus 4 all multiplied by y, and this is equal to negative 3, negative 5x. Divide both sides by 3x minus 4, leaving y here. This is equal to negative 3 minus 5x. Divide by 3x minus 4. And lastly, we are going to replace y with f inverse of x. F inverse of x finally is equal to negative 3 minus 5x divided by 3x minus 4. and hence this is said to be our inverse function if and only if this is our original function. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.